In this video, I'm going to talk to you about SR 325 standard recommendation for the design of masonry structures in Ireland to Eurocode 6. The Eurocodes are a series of 10 European standards providing a common approach for the design of buildings, other civil engineering works and construction products. They are the recommended reference for the technical specifications in public contracts. Eurocode 6 applies to the design of buildings and other civil engineering works, of parts thereof in unreinforced, reinforced, pre-stressed and confined masonry. The standard recommendation produced by the NSAI contains non-contradictory, complementary information as guidance material for the use in Ireland of the following EN Eurocode 6 standards. That's EN 1996-11, 1996-12, and 1996-2. So one thing to remember is that it's important to ensure that you have the very correct version of standards. Part 3 of the building regulations, technical guidance document A, relates to thickness of masonry walls in houses with not more than 2 floors, including the ground floor. It states that walls should be properly bonded and solidly put together with mortar and comply with the relevant requirements of IS EN 1996 and additional guidance given in SR 325. So it's important, EN 1996 and SR 325 form part of Part A. Masonry is an assemblage of assemblage of units jointed with mortar. Masonry unit is a brick or a block, and a masonry bond, a disposition of masonry of units. NSAI produced additional guidance to some harmonized standards in the form of standard recommendations, which set out appropriate minimum performance levels for specific intended uses of certain construction products in Ireland. In the case of aggregate concrete blocks, the relevant suite of harmonized standards facilitating specification of masonry units is the EN 771 series of standards, and EN 7713 deals with aggregate concrete masonry units, that is blocks and bricks. So category 1 aggregate concrete blocks are required for use in buildings. This requires third-party factory production control certification by a notified body. Aggregate concrete blocks intended to be used in structural elements must meet prescribed performances for density, compressive strength, and moisture movement and durability. In other words, they must be fit for purpose for the intended use and location in Ireland for the life of the building, which is a minimum of 50 to 60 years. Aggregate concrete blocks are required to be made with aggregate conforming to IS EN 12620 plus A1 2008 and SR 16 2016 aggregates for concrete. Manufacturers of aggregate concrete blocks must draw up a declaration of performance and affix a CE marking to the blocks or the pallet of blocks. It's the law under construction products regulations, and this must be available in a language which can be easily understood by users of these blocks. What are the obligations under construction products regulations? Well, you should have a copy or a photograph of the CE marking, a valid declaration of performance, that's the DOP, the test reports to support the declared performance of essential characteristics, and these are included in Annex ZA of the standard, data to confirm that the constituent aggregate conforms to EN 12620 plus 2002 plus A1 2008 aggregates for concrete, the technical documentation to support that the product complies with the requirements of SR 16, and a factory production control certificate for category 1 blocks. That's the AVCP, the Attestation Verification and Consistency of Performance, and it's a System 2+. The instruction and safety information. This means the means by which identified and traced throughout the supply chains. So you should have traceability, and these documents must be kept for at least 10 years. This slide just shows how the compressive strength requirements changed between the old and new standard. The minimum for a solid block is now 7 newtons and a hollow block is 4.5 newtons. For designers, it's important to check that aggregates for concrete complies with SR 16, the national standard recommendation when designing to Eurocode 6. It is also important to check that the aggregates for concrete is System 2+ for attestation and verification of constancy of performance. So in the presentation, I'll briefly outline the main elements to be aware of. In essence, SR 325 provides information on materials and components, design and workmanships. Also, Annex A gives information on masonry bonds and joint finishes. Annex B, use of replacement wall ties. Annex C, masonry units. Annex D, ancillary components for masonry. Annex E, specification for mortar. And Annex F is the national guidance for EN 13914, which is the design, preparation, and application of external rendering and internal plastering, part 1. So that's a very important part. And note, there are 67 normative reference documents which are indispensable to the application of SR 325. So you should have a copy of those 67 documents. Factors to be considered by the designer include stability, materials, mortar, accommodation for movement, adhesion, resistance to moisture, penetration, durability, fire, masonry bonds, provision of services and other construction details, and the bedding of units and other aspects of workmanship. Other design considerations include applied facing, weight of the wall, thickness of the wall, speed of construction, and accuracy of construction. TGD Part A, building regulations, requires that concrete blocks are of dense and lightweight aggregate and must be Group 1 masonry units conforming to ISEN 7713 with a minimum thickness of 90 millimeters for bearing and a minimum declared mean compressive strength of 7.5 newtons per millimeter squared. Clay bricks should have a thickness of 103 millimeters, be frost resistant, conform to ISEN 7711, and may be either Group 1 or 2 masonry units with a declared mean compressive strength for Group 1 of 9 newtons per millimeter squared and 13 newtons per millimeter squared for Group 2. Lintels should be designed for the actions and spans occurring and should be installed strictly in accordance with the manufacturer's instructions. Prefabricated lintels should comply with ISEN 8452 and the additional guidance given in SR 325. SR 325 Table 5 gives the relevant standards that lintels should comply with. Annex D2 gives the requirements for mechanical performance and durability, which should be the same as the design life of the building which they are to be used in. Now, you need also to refer to Part D of the building regulations. That's to make sure that these lintels are fit for the purpose. And I draw your attention there now in the slide to figure 14, page 65, which outlines a steel lintel with separated damp-proof course. If you look at section 5.3.4, it outlines the requirements for support over openings. And the thing to remember is that masonry should be set out to provide a full block under the bearing. For workmanship, see section 6.4.9.4. The thing here to remember is that lintels should be bedded on mortar. They should not bear on a short length of cut block. If propping is required, instructions for the propping the lintel should, during construction, including the maximum spacing of the props in millimeters and the load that can be applied during the installation of the lintel must be considered. The props should not be removed until the masonry element of the lintel has achieved its design strength. So in the slide is an example of a manufacturer's instruction for composite lintels used in aggregate block construction. For concrete lintels, make sure that it is built in with the reinforcement in the correct orientation. Usually a marker is cast into the lintel to indicate the correct installation orientation. It's good practice to prop steel composite lintels at centers not exceeding 1.2 meters during construction, but make sure and follow the manufacturer's requirements. Make sure that all joints are solidly filled and exposed surfaces of lintels are provided with fire protection. Avoid point loads immediately above the lintel unless proven by a structural engineer. Many factors influence the selection of wall ties. So I'm talking about wall ties now, including the type of masonry to be tied, cavity width, type and height of buildings, and the geographical location. For cavity wall construction, the leaves should be tied together with wall ties comply with IS/EN 845, should have a minimum mortar embedment of 40 millimeters to the other face of the wall at a frequency of not less than those given in the National Annex to IS/EN 1996-11. So remember that additional ties must be provided within 225 millimeters of all openings, one for each 300 millimeter of height of opening. Important to provide additional flexible ties across the cavity adjacent to movement joints. So follow the manufacturer's instructions, stick with the standard. If you're using a hollow block to form one or both leaves of a cavity wall, make sure the ties are placed on solid sections and has adequate anchorage. Where possible, ties should not be installed at DPC level and should not exceed 225 millimeters above any DPC of the first row. The maximum height of wall panel above the top row of cavity ties should not exceed 225 millimeters. So reshaping or bedding of wall ties is not permitted. Bending and reshaping is not permitted. Need to watch that each tie is placed, that the drips will cause water to fall within the cavity away from the cavity fill. And in the slide, you'll see a properly placed tie where the drips are placed properly. SR 325 Annex D, and that's D1, provides the recommended minimum declared mean load capacities for wall ties used in buildings in Ireland. So of note, this annex is informative and must be interpreted as specifying requirements other than those contained in the normative parts of the European standards for these products. So watch out for that. For cavity widths greater than 150 millimeters or dynamic pressure greater than 1.1 kilopascal, specialist design and manufacturer's guidance must be sought. Technical guidance document A of the building regulations specifies that wall ties should comply with IS/EN 8451. And EN 8451 states that the materials and protective coatings materials for ancillary components, the appropriate protective coatings shall be selected from table A1, so table A2 or table A3. So make sure you get and check the declaration of performance for your wall ties to ensure that they are fit for use. Watch out for workmanship, in particular embedment, no bending and drips. Where possible, to control the contraction in concrete masonry, it should be designed as a series of panels separated by movement joints. As a rule, vertical joints should not be less than 10 millimeters wide to accommodate horizontal movement and should be provided at intervals not greater than 7 meters. The ratio of length to height of the panel should generally not exceed 3:1, and particular attention is drawn to long, low horizontal panels of masonry like those under windows. Careful consideration should be given to the effect of introducing movement joints. And section 5.4.3, placing of movement joints in SR 325, so says movement joints should be formed as the work proceeds and should extend to the full height of the building and should not be interrupted by openings, windows and doors. And that's just from the NHBC there in the slide, just good practice guidance. Table NA2 of the National Annex to IS/EN 1996-11 to Eurocode 6 gives the recommended maximum horizontal distance between vertical movement joints for external, unreinforced, non-load-bearing walls. Spacing of these joints may also be obtained by calculation, so don't forget your calculations to double check, making the appropriate allowances for material properties, because the materials mightn't be the same as that used. The slide shows a good and a bad movement arrangements. Again, that's from the NHB good practice documents. The material for filling movement joints should accommodate expansion, should be easily compressible to approximately 50% of its original thickness, and movement joints should be sealed for resistance to water penetration. I would always recommend that, sealed for resistance to water penetration. And durability now. A major factor influencing the durability of masonry and applied finishes is the degree to which the construction may become saturated. And nearly everything in Ireland will become saturated at some stage, with water either directly from rainfall or indirectly by water moving upwards from the ground, or laterally from retained material like a retaining wall. External masonry is much less likely to become saturated where projecting features are provided to shed runoff water clear from the walling, such as examples of projecting features include roof overhangs, copings, projecting throated sills, bell casting to renderings, slate or tile hangings, or other impermeable cladding. And you should consider that in exposed areas. Durability of masonry is dependent on surface finishes, workmanship, architectural features, weather, etc. So moderately porous uncracked rendering complying with ISEN 13141 or by a ventilated cladding such as slate or tile hanging will keep the masonry in a drier condition. The quantity of rain falling on a vertical surface such as a wall, any point depends on both the intensity of the rainfall and the wind speed. So watch out for that in your design, rain, moisture. So I draw your attention to SR 325 table 14, which deals with durability of masonry in finished construction. Masonry 150 millimeters above and below finished ground level is most vulnerable and can remain wet for very, very long periods. So selection of materials fit for purpose here is very important. SR 325 Annex F gives advice on regarding the application of ISEN 13914. And this slide F1 gives guidance for prescribed mixes suitable for rendering for weak backgrounds in sheltered locations. So watch out for that and become familiar with that. Table F2 gives guidance for coat thickness and number of coats for severe exposure conditions, which is most of Ireland and in particular the West Coast. The map here in this slide outlines the driving rain index for Ireland, showing almost every coastal county in the severe exposure range. For severe and very severe exposure class conditions, the use of two undercoats with a thrown or rough textured finish to shed rainfall is important. Classification of exposure to wind-driven rain includes sheltered, moderate, severe, and high buildings. So SR 325 recommendations for the design of masonry structures in Ireland to Eurocode 6 is not simple, and masonry structures should always be designed and built by competent professionals and competent builders, competent designers. And I can't reiterate that enough. Thank you.